And Adam, I'm going to go ahead and make you presenter.
All right.
Have a great session.
I will attempt to present some stuff. Thank you. All right. Hopefully everybody can see my screen. Now that looks good. We're going to talk today about operational best practices for analysis services 2008 R2. The reason I have a hyphen in there, slash in there, is because really everything we're going to talk about primarily applies to both of those versions. So our real focus when we talk about operational best practices is going to be to kind of condense some of the information that you get from the Analysis Services Operations Guide, which is a white paper that's published out on SQLcat.com. And if you want to go take a look out there, it's a really, really good read. It's about 96 pages. So as you can imagine, I have 96 slides that cover everything that's in that book. So I'm just kidding. But we are going to go through some slides just talking about things that we're going to be able to do to configure our server more efficiently, to be able to optimize our I/O performance, to be able to improve our query performance, as well as to make sure that we're able to monitor those things. So how do we know that we're actually improving? We don't know unless we actually are able to monitor and see this is our before, this is our after. So the first thing we're going to talk about is configuring the server. You want to make sure that you have an operating system, very important, step number one. But even more important than that, make sure that you have all the recommended hotfixes. A lot of organizations have, obviously delayed implementation for hotfixes and service packs as they go through testing. A lot of those hotfixes are performance and scalability related. With the cumulative update that just came out recently for SQL Server, Microsoft released almost 96 MDX performance improvements or performance fixes for functionality that was where MDX was not behaving as expected in analysis services. 96 sounds like a big number. It is. It's a big impact for a subset of a product as small as MDX. But in the grand scheme of things, it's overall a relatively stable product. The hotfixes especially, there's a specific hotfix for 2008 that's included in 2008 R2 that will help optimize for asynchronous I/O. If you're running Kerberos, congratulations and my condolences all at the same time. Kerberos is a little tricky. That may be an understatement. Some of you are probably laughing in the background, but Kerberos is going to require a couple of additional hotfixes on all the servers that are involved in authenticating back to your analysis services environment. So good things to just be aware of as you begin to configure your server before you even get to the analysis services side of things. Once you get into analysis services, then we have our INI file configuration. So the INI file is going to store a lot of our settings, and this isn't all the settings in the INI file. These are just most of the ones that people actually may or may not go in and change. I wouldn't recommend changing many of these without talking to an escalation engineer on the analysis services support team. But there are a few that you can adjust, and some that we'll talk about through the course of today, like memory heap type and heap type for objects. That's going to increase our throughput for high concurrency systems, really sort of optimizing for multi-user, which we'll talk about in a little bit. Hard memory, low memory, and total memory, we'll talk a little bit about those. Our goal with those is really to make sure that we're taking the best advantage of the economical memory management process that analysis services uses, and I'll talk some more about what that means when we get to memory. Coordinator execution mode and coordinator query max threads, those are controlling the concurrency of your ability to run queries. Coordinator build max threads is helping to control the concurrency and the number of threads when you're doing processing or pulling data into the queue. Your aggregation memory limits, you also have buffer memory limits and buffer record limits. Being able to increase those is going to really help with processing speed, but it will consume more memory, as you can see on the slide. The reason that it helps during processing is the more memory you can bring in, or the more data you can bring in per buffer, the better your compression is going to be when it goes down to the disk. So we're going to be able to find more duplicate data per buffer segment in order to reduce the overall size of that buffer as it goes into our eventual data store. The next few we really don't mess with very much. Those are really session timeout variables and things like that. If you're getting a lot of timeouts, talk to CSS, and they can help guide you as to what the best value for that really should look like. Allowed browsing folders. For those of you who are relatively new to analysis services, you've probably been very frustrated when you go to restore a backup and you try to browse to the folder and it doesn't let you. You need to make sure that whatever folder you're going to put your backups in is in this tag, in this list, and you can actually edit this through the advanced properties of the server through Management Studio as well. Many of these properties can be edited through the advanced server property window in Management Studio. If you right-click on the server, go to Properties and say Show Advanced, there's a little checkbox at the bottom. Many of these will be in there, but not all of them. That's why it's important to know where your INI file is in case you need to go out and make an edit. Your temp directory sounds a lot like tempdb, right? So people probably think, well, you need to make sure that's really, really tuned. It sort of has the opposite effect in analysis services. One of the counters that we'll talk about later shows why your temp directory really shouldn't see a whole lot of action. If you look at what it's used for over here, controlling where disk spills go, obviously a disk spill is a bad thing. So if something is happening in their temp directory, typically we may be experiencing some performance challenges or some bottlenecks that we want to address. When we talk about memory configuration, memory in analysis services runs on what's called an economical memory management model. So every time something is pulled into cache, it gets an income. So it's being used, it's valuable, so it gets $1, for instance. Then every time that it has to sit there as the memory clerk comes by, if the system's not under a lot of pressure, it'll come by and say, hey, give me 5 cents, and you'll say, oh, I got enough income for that, I was valuable enough to get $1, here's 5 cents. Now, as more memory begins to be consumed and available memory becomes more valuable, staying in cache is going to cost more money. So as it can, hopefully it's been used enough to get enough income to pay its taxes, but if not, it will age out. It'll say, look, you don't have enough to pay the tax, you can't stay in cache, you're going to have to be aged out until we need you again, we'll bring you back. And so we have two kinds of memory that get cached. Really, we have shrinkable memory and non-shrinkable memory. And the shrinkable memory is really your data cache, your calculation cache, and your paged in dimension data. That data can be easily moved in and out of cache whenever the system becomes under memory pressure. Non-shrinkable memory is typically only attacked when we're looking around our total memory limit or our hard memory limit. And it's going to start deallocating memory pretty aggressively from not only shrinkable memory, but if you get to the hard memory limit, non-shrinkable memory is going to start being affected. So even active sessions will begin, to be selectively killed. Query memory will begin to be severely restricted or taken away, resulting in query timeouts and query failures. Obviously, we want to stay away from that. So make sure that your system is appropriately sized and appropriately monitored so that you can watch and make sure that you're not getting very, very close to these particular values. When we are monitoring memory, make sure you go out and find some resources that teach you how to use perfmon. Most people don't wind up looking at memory counters in perfmon. They just look at maybe memory in use just to see the trend next to their CPU, and that tends to work pretty well. But when you look at the analysis services counters, because of the way that they scale, they're not going to look quite right. So you could scale them. You could scale them automatically, which is the picture on the left, and it looks like there's no memory issues because usage doesn't even get close to our limit. The problem is if you look down here at the bottom, you'll notice our memory usage is on a different scale. Once we fix the scale, now we've got some problems. So the value of our high memory limit is only 12 meg, and we're way, 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 way up here. Significantly higher. So what we need to make sure that we're monitoring is all of our counters, but on the appropriate scale to make sure that we're actually seeing the results that we want to see. Also, we can change heap settings and data store page size. Really, increasing that page size is going to allow us to have a greater data volume in our hash tables that are created at query time. Aside from just reading that off my own slide, what I can tell you about that is when you want to be able to run a query with a large amount of data, those hash tables and the performance of those hash tables are critically important. because if you know a little bit about analysis services and how it stores data in a large number of individual files on the file system. It doesn't have NDFs or LDFs like regular SQL Server relational databases do. So a lot of those files are constantly being accessed, and that data is constantly being pulled in. And as it's being pulled in, it's being hashed. So a lot of those files are string data that got put out to a string file. There's attribute key files. There's tracking key structures. There's decoding stores that are decoding attribute relationships. All of that data is being pulled back in and being manipulated by the OLAP engine inside of analysis services to return you your query results. Being able to bring more data in at a time is obviously more memory pressure, but if your modern hardware system can handle it, it'll give you a dramatic boost in performance. Also, we can change these memory heap types to multi-user, which is going to allow for a lot more concurrency in your environment. Really what multi-user does, which I believe I have, and I know I have an upcoming slide, so we'll talk a little about that in a minute. But it's going to really provide the ability to, instead of using more resources for one thread, it's going to multi-thread that a little bit more effectively. The default, though, is for single users. So for developers, you just want to remember when you deploy to production to actually test some of your longer queries in a multi-user heap mode, even on your desktop, just to make sure that the optimization and everything is still working correctly. We've also got thread pools and CPU configuration we need to think about. So we've got questions around processing threads and query threads. The processing threads, the main thing you need to know here is the default is 64 threads or 10 times the number of cores, whichever is greater. So if you have an 8-core box, what's your default process maximum number of threads? It's going to be 80. On the query side, that's going to show you the number of threads that are available to the formula engine for answering queries. Keep in mind that's the formula engine, not the storage engine. So there's two primary engines in analysis services. We have the formula engine and the storage engine. The formula engine is the engine that's doing the execution plan, the coordination, the scheduling of, hey, storage engine, go get me this data, and then this data, and then this data, and then I'll put it all together. So a lot of that coordination needs the multi-threading, but the storage engine has a lot of threading capabilities as well to make sure that it's able to do partition elimination, to be able to handle partitions with to scan across the correct number of segments per partition, et cetera, et cetera. So we're not going to get too much into the internals of how some of those partition structures are created, but if you take a look at my blog out on adamjorgensen.com or the SQL Cat blog, there's a lot of good information out there as well. And if you guys have questions on that, I can maybe do another webinar on internals or things like that if that's really interesting to people. Execution settings. So we talked about a couple of different pieces of the puzzle when it comes to actually executing the query. Up here we have our formula engine thread, and then that's going to hand off to our process max threads, and this many coordinator jobs, that's controlled by our coordinator execution mode. So what we've got here is, let's imagine we have a table with 100 partitions, or a measure group with 100 partitions, and we have 1, 2, 3, 4, 5 segments, which are really just a portion of a partition. It's aligned by analysis services. They have some default sizes. And then we have 1, 2, 3, 4 threads that are running right now. So one of those segments is going to have to be scanned again. So there's 5 to 4. Then those are controlled by the coordinator query max thread. Once you understand some of these internals and you understand how this process is pulled together, it's a lot easier to back into some of these numbers. So you can say, well, I have partitions of about this size. That's going to mean there's about this many segments. And my queries typically pull from 3 out of my 5 partitions. So if I'm going to scan all 3 of those partitions with that much data, I'm probably going to need this many threads and potentially this many coordinator jobs. And you can kind of back into those numbers and dial it in with a little bit of testing. So just a kind of visual way to sort of identify and put some pictures to names when it comes to all these different settings. Here it is, multi-user mode. I'll have to move this slide up a little bit. But what we really want to see is the difference between the default settings down here and the multi-user settings up here. In the default settings, Query 1 issues 720 total segment jobs. So out of all the partitions, there's 720 segment jobs that get created under the covers to go get your data. All 720 of those jobs are spawned from that one query. So those are all going to go run. So there's no more threads available for queries 2 and 3, and they get blocked. Well, that's not good, because query 2 is Susie in accounting, and she's processing payroll. And so if that's blocked, we want to make sure that everybody can get paid. So what we've got instead with multi-user mode is it's only going to use a portion of the available threads to allow for other queries to make it through. It optimizes for concurrency. The logical question is, well, what's the maximum percentage it'll use, or how many will it use? And the short answer is nobody really knows. It's all based on the workload. There's an algorithm that's built into analysis services now that takes care of that. Really only maybe Jeffrey Wang. Jeffrey Wang is one of the developers on the analysis services team. Very, very knowledgeable guy. He owns the formula engine piece of analysis services, and he has a blog out there. I don't know the address off the top of my head. I believe it's on MSDN. But I'm sure if you go out to your search engine and type in Jeffrey Wang, SQL, and analysis services all in the search box, it will pop up pretty quickly. So again, we're definitely recommending multi-user mode for most things. Unless you really just have one app that's just going to run sequential queries, then default might be better. But for the most part, multi-user mode is going to be a little bit better. All right, partitioning, storage, and striping. So I consolidated about 6 slides down into one for this presentation, because there's actually a whole hour session that we do on partitioning, storage, and striping. But it's a little bit boring, and so I didn't want to put everybody to sleep, so I consolidated. The important thing to remember with analysis services is random I/O is king and queen. You do not have sequential I/O when it comes to analysis services. What you have is you have a whole bunch of individual threads doing sequential I/O, but they're all doing it over top of each other and in a random order, which in turn means it's random I/O. Taking advantage of NAND or flash storage like a Fusion I/O or a Violin memory array, those types of technologies are hugely beneficial for the performance of these analysis services environments. Again, remembering that it's difficult to physically spread out individual partitions from measure groups on the disk, because they don't really move around very easily. Typically, the approach that's taken is really a stand mega LUN. And what we mean by that is one very large LUN on your storage, whether it's a flash or NAND-based array or a traditional SAN, or even just an internal drive for a smaller cube. That's really optimized for highly aggressive random I/O capabilities. So if you ask your storage administrator or your storage vendor, they can tell you what things they recommend for their storage to make sure it's optimized for random I/O. We can also look at doing dynamic disk stripes, which spread the data across multiple spindles. If you're having to do, maybe direct attach storage or something like that, there's some really cool techniques that we can leverage to make that disk as fast as possible. You also want to make sure your allocation unit size is 32K. That seems to be the most well-tested value for larger analysis services environments. Don't sub-optimize. What I mean by not sub-optimizing is don't try to get so granular that you make your life really difficult. And a good example of that goes back to moving partitions around. The webinar that I did on this past Tuesday, we talked a lot about some case studies that Microsoft has done, and Yahoo, of course, is one of them. And Yahoo has a very large analysis services environment. I think at the time of writing the white paper, it was 12 terabytes. I think now it's almost 18 terabytes, just their cube. It's the largest production cube in the world, to the best of my knowledge. And they have sub-optimized at this point, but they will tell you that they have basically 2 full-time people that do nothing but manage that partitioning in the cube. That's their entire job. And they run a lot of scripting and a lot of things just to move those file systems around and update the XML under the covers and all that kind of stuff. And it can be very, very challenging for them to make that work. So they've been able to make it work, but for most organizations, not required. Just optimize your storage, put everything in the same place, and you should be in good shape. Keep in mind that analysis services is going to give you somewhere between 50 and 70% compression on your data on its way in from the data warehouse. So if it's a terabyte of data, for instance, that you're bringing in, most of the time you're only going to see somewhere between 300 gig and about 500 gigs worth of data in your cube. So that's a really important thing to understand, especially when you're doing sizing and capacity. Defrag your data folder. How many of you guys ever thought you would see a presentation that said to defrag your data folder, right? Unless it was a SQL vendor tool? Because they are just file system files, defragging actually helps performance on a regular basis. So I would recommend that. Definitely defrag your directories where your analysis services files are stored. Obviously avoiding any NDF or LDF or MDF files from SQL Server, but hopefully those aren't sharing the same directory. If you don't know what your storage is doing, for instance, if you say, I don't know how fast my storage is, how is it going to perform at an analysis services load? If you look at the operations guide, there are more examples of SQL.io scripts that you could run. Excuse me. There are more examples of SQL.io scripts that you can run that are going to generate 32K allocation size random I/O across a particular file for a certain size, and then you'll be able to get timings and other readings and performance based off of how many of those threads that you want to kick off. So you can get a lot of really good information out of that. Your network configuration, one of the most often overlooked options for processing is if your environment happens to have the analysis services cube and the SQL Server data warehouse or SQL Server source share the same physical machine, which in a lot of cases as you're growing, that's going to happen because you're not just going to rush out and buy a new piece of hardware for a tiny little cube that you're building. You can use the shared memory network protocol. Shared memory is many, many, many times faster than TCP/IP because it never has to touch the IP stack. It goes straight from one memory buffer to another back down the disk. And there's some good examples on how to do that and how to make sure that that works well for you in the operations guide. If you want to see some results, these are some results based on some testing that was done for the guide, and I have seen very similar results in real life. About 112,000 rows read per second peak with TCP/IP, about 180,000 rows per second with shared memory. So keep in mind that's one thread. So as you're pulling multiple threads, that count and that differential is going to go up really exponentially. So just kind of keep that in mind as you're building out your environment. Miscellaneous network settings. These are really important. You need to have jumbo frames enabled in order to process that much data, especially if you're working with very large cubes. If you're working with small cubes, not a big deal. But just remember that all of your hardware needs to support jumbo frames, and it needs to be enabled all the way from server to server, and even potentially out to an app server if you have an application that's querying it. So that includes the network infrastructure and the servers and anything in between. Your TCP chimney, most of you didn't know your house had a TCP chimney. Your TCP chimney is basically a queuing mechanism on your network card that had some issues in SQL 2000. There was a hotfix for it, didn't go very well. I can remember being at Toyota and having that just blow up all over our clustered nodes after that hotfix was applied. We had to go out and roll it all back. So a lot of people got gun shy about TCP chimney, but it's all been fixed. Everything in Windows Server 2008 and 2008 R2 is good to go. So make sure that that's turned on and configured correctly. If you have DBAs who've been working with SQL for a while and actually are pretty savvy with the Windows operating system, they may have disabled this, rightfully thinking that it might be a performance issue, but in reality it will usually boost performance. So it should actually be turned on and configured. You also want to remember if you're in a virtual environment, we have a lot of clients who go virtual. That's cool. I have no problem with virtualized environments for analysis services as long as they can keep up. Typically where virtual environments suffer is latency on your virtual networking adapter and I/O performance, right? So one of the things that we want to be very, very careful of that's critical to analysis services performance is making sure that those files are in a location that's highly optimized for random I/O. So if you can deliver that through your virtual environment, which you can if you do it correctly, then more power to you. But just be careful with that because you will tend to run into bottlenecks a little bit earlier in the cycle as opposed to later. We also want to make sure that we increase our packet size for the network to 32,767. That's going to allow us to push more data through, obviously per packet. And then on top of that, that's going to allow us to match our packet size to what we're probably using in integration services. We want to make sure that the data that we're pushing through, if we're doing any kind of incremental processing or anything like that, we can take the most advantage of the types of things that we're going to be able to see as we begin to load data into our cube. So just food for thought there as far as some miscellaneous network settings. Using multiple NICs, there's a section in the operations guide that talks about that. Not a lot of folks will get into that, but you can actually partition your data source across multiple network interface cards. And then when you do your processing, you can take advantage of all of the individual throughput for those individual network cards per data source. So if you have data sources that can take advantage of a higher throughput than others, you won't have them bottlenecked. So just some good information there about your networking settings. When we talk about monitoring and tuning the server, that's really important because now that we know what some of the things are we should do, now we have to know how we go check it out, right? So what's going to be really important as we begin to go check it out? I put this slide in here. I'm just going to leave it up here for a second so you guys will have the list as a reference, and then we're going to break it down and talk about some specific kinds of things that I want to make sure we target. Of course, memory counters are very, very important. Processing aggregations, all of these proc ones that you see, they're all for processing. So processing aggregations, that counter that says temp file bytes, I'm going to learn how to talk today, temp file bytes written. And then there's another one that we'll talk about in a minute, another counter that's actually temp file bytes written per second. And what it's doing is it's really measuring how much temp space we're having to use. And temp space only gets used when we run out of memory. So really, if you're seeing that grow at all beyond 0, you probably have a memory constraint. That's just something to be aware of there. You can also monitor from a processing perspective how many rows are being created per second for indexes as well as processing, so you can tell if what you're doing is speeding up your processing or slowing it down. There's also file read operations per second. That's going to measure your IOPS from the file system cache. That's a very, very important number. As well as your MS OLAP threads. So really all of those thread counters, that's why there's a star in there, are really, really important to understand and really kind of dig in on if you're going to have to do any kind of tuning in an analysis services environment. So with that, let's talk about some ways to find out what's going on in the environment. Excuse me, guys. I'm losing my voice. 2 webinars in 1 week. All right. We've got some dynamic management views to work with, and these are not all of them, but these are a lot of the most common ones that people will use. Our Discover Commands DMV is going to list all of our currently running commands. Kind of think of it like an SPHU. Our Discover Sessions is going to list all the sessions on the server. And connections, probably going to tell us which connections are there. So typically, to really get an equivalent for SPHU, we really are going to get Discover Connections, Discover Sessions, Discover Commands, and sort of union those together and get a nice cross-section of what's actually going on our server. We've also got Discover Memory Usage. That's a really important one because it'll actually tell us what's allocated, where we're allocating our memory, as well as what's been holding memory the longest, and if anybody's blocked from getting additional memory, if anybody's waiting on memory. That's going to be a really important thing to understand. We've also got Discover Locks, so we can run queries in there to make sure that we're not seeing issues from a single or multi-user mode type of scenario where there's the thread starvation on the system, or we're not able to get enough processing power pushed through. So there's a lot of really cool things we can do here with these DMVs. When you begin to test your cube, there's some really important things that you want to make sure you do. We can talk all day long about the administration and the server side and all those types of things, but at the end of the day, where I see most projects that are new or going into production really fail is their test plan is just dismal. And most of the time it's just, hey, the developer did their unit testing, and it's really not much beyond that. The end users may have run some reports, they verified the reports, but they were the only ones who ran them. They ran them 2 or 3 times in a short period of time. All the data got cached nice and clean. And in a perfect world, cache is not clean. So if you pick up, I like to tell people, if you pick up $1 off the street in New York City, you're probably going to wash your hands. Same thing. We've got cash is not always going to have what you need in it, and so you need to understand, really what to test from an ASQ perspective. And so we'll go through a couple things right here. You want to make sure you touch queries, you run queries that touch several dimensions at the same time. That's very, very important, largely to make sure that you're getting the right performance from different dimensions and that you're seeing the correct dimensionality and that you're not getting errors. You want to make sure that you have enough queries to test every MDX expression in the calculation script. So if you have 150 calculated members and scope assignments and all these other things in your cube, you don't want to just run a couple of simple queries and go, yeah, my calculations are right, or I threw something in Excel and it looks pretty good. You want to make sure you really exercise those calculations. Also, stack the calculations. So write queries that are going to pull back multiple calculations in a row. You can check for path or solving order problems or solving order errors. Keep in mind, we're working in a multidimensional world, so that when analysis services begins to do scope assignments, we're overwriting part of the underlying subcube. And when we overwrite part of the underlying subcube, what tends to happen is if we go to reference that while it's been overwritten in the same session, we can get mixed results. So that's a little bit of a challenge. So you want to make sure that you leverage those and that you test and validate your data. You want to make sure you exercise, more traditional features in analysis services, but things that typically have to go out the window as you scale, like many-to-many dimension, custom roll-ups. I want to add this except when it's blue, and then I want to subtract it, and except when I get it from Rachel or Melissa, and then I need to count it double because they're such good help, or it just really doesn't, whatever kind of custom roll-ups you want to do, those things take a lot of activity in the formula engine and a lot of work from the formula engine to calculate. You want to make sure if you have parent-child dimensions that you absolutely must have that parent-child dimension, first of all, because parent-child dimensions should really be avoided. They're performance problems. But if you absolutely have to have it, I had a client the other day tell me, well, you don't understand why we have parent-child dimensions. And I said, no, I do. They're very convenient. They're a lot easier to build. The problem is they perform like, pretty poorly. So you want to make sure that if you have a parent-child relationship, as it begins to grow beyond, maybe 10 to 15,000 rows, that you flatten that out into a more traditional dimension layout from a data architecture, data modeling perspective. You want to make sure you exercise your distinct count measure groups. Distinct count measure groups are the slowest performing measure groups known to mankind. It's very difficult to optimize them. So you have to make sure that they're not very large, and you have to keep them maintained, and you have to have a realistic expectation that when the end user goes to grab a sum and then a distinct count, there's a distinct possibility that it could take a lot longer. And so that can be a little tricky. You want to make sure that you cross-join attributes from very large dimensions. The optimizer has some slightly different ways that it handles things from very large dimensions, and we want to make sure that we exercise that appropriately. We also want to make sure we have queries that touch every single partition. So we want to make sure we scan every partition to see if any one of them is taking any longer than absolutely required. In order to see some of that, you can pull that in Profile. You can actually connect to analysis services and see what's running, get your duration, get all your information about your queries. Excuse me. We also need queries that return a lot of data. So not just data that queries that touch a lot of data, but queries that return a lot of data. Let's make sure that our network and our pipe and everything like that is looking pretty good. Preferably, when I do that test, I like something that has more than 100,000 rows. If you have cube security built into your cube, you need to make sure that you're testing that as well as the traditional analysis services security. Also, if you have any queries that are going to execute concurrently with processing operations, first of all, really think about that. And if somebody's telling you that, we absolutely have to have that, it's just the way it has to be, slap them in the mouth just once, and then if they're still sticking with their story, say, great, we'll make it happen, and then test it, because you're really going to need to understand the impact. You should really, obviously, as you can tell by my comment, desperately try to avoid running queries in the middle of processing. There are ways to do real-time processing and ways to offload some of that. so that those queries aren't running directly in the middle of a processing window in particular. When we talk about high availability and disaster recovery, there's a number of things that we can do with analysis services to make sure that we have availability and recoverability options. Of course, we have backup and restore, very traditional, very tried and true. We can do a SAN-based backup, so if your SAN has disk-based replication or snapshots or things like that, a lot of times that will work as well. We also have synchronization, which is built into analysis services, which performs pretty well up to a certain scale, typically up to about a 20 to 30 gig cube, and then synchronization may have some performance challenges. Excuse me. Keep in mind that since these are all just files on the file system, a great tool like Robocopy will also work. So you can set up Robocopy to just copy the files that have changed potentially overnight out to your DR server, restart the analysis services service, and the new cube will come online just like it was before. We can also cluster analysis services. It's not the easiest thing in the world to cluster, but it can be done, similar to the way that we do things with integration services. And we can leverage a lot of the sort of tried and true storage techniques to make that happen. It actually makes it a lot easier since all the data would typically be on one volume. That one volume could be relatively easily shared between a couple of different hosts, if need be. So if we're diagnosing, excuse me, if we're diagnosing and optimizing our cube, now that we've done all of our testing and we said, well, this looks pretty good, but this other query over here, it looks like there might be some issues. Processing could be a little bit faster, so let's dig back in and make this thing really great. If we want to tune our processing, the best thing you can do right out of the gate is switch from a process full to a process data and process indexes phase. The process data is then going to just pull the data in, and the process indexes phase is going to build all the aggregations, bitmap indexes, and regular indexes on the cube itself, or on the measure group that you're processing in particular, and its affected objects. In order to tune that process data piece, you want to make sure that your relational source is fast enough. It's then going to look up those keys and populate the processing buffer and then write that processing buffer to disk. So what two subsystems are we using here the most? Memory and storage. We want to make sure that those are really tuned and really operating at peak efficiency. To optimize the relational engine, remember, we're pulling data out for the most part. We kind of control when we put data in, so we've got a lot more flexibility there. But when we want to do processing, our primary focus is trying to make sure we leverage a very high fill factor for our indexes, as well as using compression for our larger tables, because compression is going to make sure that we're doing a lot less physical I/O to bring that data back and bring that data into the environment, especially if you're in a virtual environment. So a lot of people say, well, compression has a lot of CPU overhead. Not really. It doesn't add a significant amount of CPU overhead. It will add some, there's no question, but the compression and decompression actually happens in memory. It doesn't happen on the disk, so it avoids thrashing your disk. Usually in most environments, you have a lot more room, a lot more overhead in your CPU than you do in your storage from a performance perspective. We also want to make sure that we eliminate locking wherever possible. So we can make sure that we issue queries with certain types of read-only lock hints, as well as potentially a no lock if that's feasible, if it's not financial data. Or we can build our fact indexes and say locks off, just to make sure that we're trying to avoid impacts to the production system if it's a 24/7 system. Loading from Oracle, my favorite thing to discuss. If you are loading data from Oracle, you really cannot tune your relational system. Don't get me wrong, Oracle is a very established and worldwide, very, very large-scale product from a market footprint. But at the end of the day, their drivers are pretty terrible. So you can either go out and spend big money to get the Attunity drivers for Oracle, and those are supported and they work great. Or we can basically bulk out that data from Oracle and put it into SQL Server, and then get somewhere between an 8 and 10 increase per core from a throughput perspective out of SQL Server into analysis services, even remotely over the network. I have actually seen processing tests go higher than 6.1 million rows per second. I can hit somewhere just under 1 million rows per second on my laptop with a traditional 7200 RPM drive, and get a little bit over 1 million with a solid state drive. That's using shared memory. So you can definitely get a lot of power through that by just moving that data over to SQL Server in the first place. Just stage it there and then bump it in. We talked about avoiding locks. We have lock contention that we may have to deal with. So when you run Profiler and you take a look at these lock events, lock waiting, you're going to see the hold list, which is going to show which transaction is currently holding a commit write lock on the database versus the wait list, which is really indicating that some other transaction is waiting for a commit write lock on the same database. So it's waiting to be able to write. The other one is still writing. So that's part of the challenge. It'll tell you the object. The nice thing is you can go in and sometimes be able, if it's a long-running process, sometimes you can pull the processing logs and look and try to identify which individual object that is, and try to make sure that it's split out, so to speak, so that things process a little bit more efficiently. Server maintenance. We talked about defrag already, but really clear your log files and your dump files. Those are gonna fill up. It gets very difficult to troubleshoot issues. When those are, just gigs and gigs of size. A lot of this is common sense, but we notice in a lot of organizations where analysis services is being used pretty heavily, a lot of times the BI folks are administering these servers, and so they don't have the same traditional background as those great Windows administrators who know all the little ins and outs of what to do to really dial up the Windows performance. Make sure you're checking your Windows event log. Have some kind of monitoring system in there. Run your disk checks. Run your defrags. I mean, just common sense kind of stuff. So, but very, very important in an analysis services environment. Some special considerations. Those of you guys who were on my webinar on Tuesday, you already saw this slide. But we want to make sure if we're using ROLAP, which is our relational OLAP storage mode, where we basically leave all the data in the relational database and we let analysis services go get it for us. It is by far the slowest from a query performance perspective. It's the fastest for a processing performance because there's really nothing to process. And it's also the best for, really true real-time data, because as soon as the data winds up in the underlying system, it's available as a cube. So the challenge with that is, of course, if we have to do distinct counts, then we need to make sure that our partitions are set up appropriately, that everything is evenly sized. The thing to keep in mind with whenever you're using distinct count or you're using ROLAP, there's a ton of great resources you should read ahead of time. Out on SQLcat.com, just look for ROLAP, R-O-L-A-P, and you'll see a bunch of stuff from guys like Thomas Kaiser and Denny Lee and other folks over there who are really I/O-centric kind of guys. They really are focused on performance and scale. They've got a lot of great tips for how to make sure that ROLAP really performs optimally. So to kind of wrap up, I wanted to leave a little bit of time for questions. You want to make sure you check out that 2008 operations guide on SQLcat.com. Try to optimize your I/O for random I/O. I cannot repeat that enough, so I'll do it again. Optimize your I/O and your storage for random I/O, not sequential I/O. If somebody tells you, or if a SAN vendor or somebody tells you that analysis services does sequential I/O, then you need to have them call me. Hit me up on Twitter, send me an email, call our office here at Pragmaticworks, get me on the phone. I'll be happy to talk some sense into that person for a few minutes for you. And make sure that you're on your way. And just be sensible. If you think about what analysis services is doing, it's accessing and pulling data out of files into memory very, very quickly, back and forth, back and forth, back and forth. So you want to make sure that everything that you're doing is going to support that type of operation. And if you're not familiar with what to do to support that type of operation, see bullet point number 1. Go check out that operations guide. Feel free to email me or hit me up on Twitter. If there's a topic that people are asking for, I'm happy to blog about it or do another webinar on it, and we'll take it from there. So with that, here's all the different kinds of places you can find me. You can also find me on my blog at adamjorgensen.com. I'm going to be at all these different events, SQL Saturdays. We just did 24 hours of PASS. We've got PASS Summit coming up. As well as all of my blogs are posted on our community site as well, bidm.com. So Keep in mind you can come here at pragmaticworks.com, find all of our free training either Tuesdays or Thursdays. There's a lot of great past webinars that are up for people to see, and stream down, and all that's free to access. So some really good stuff that's out there. Please take advantage of it. And I think we're in luck because I think Melissa and Rachel, I think we still have some time for some questions, if we have questions.
Hey, Adam. You ready for questions?
I think we are, yeah.
All right. You got quite a few in the box.
All right. Well,
Can you see them?
We can just start at the top.
You want me to read them for you?
Sure, yeah.
Or do you want to go through them?
Here's one. I'll go through them. Here's one from Parker. It says, could you recommend a good place or tool to learn about perfmon? There's actually a good MSDN article on perfmon, as well as I'm sure a couple of quick Google searches would walk you through some basics of using perfmon. Perfmon's a relatively straightforward tool to get started with, and it's a lot of fun because it gives you a lot of really good information. So yeah, I would definitely recommend checking that out. Wayne wants to know where we can download the slides for later reference. Wayne, some of this stuff is still in flux as far as recommendations that are coming out for SQL 2012. So pretty soon I'll have some of this stuff posted out on my blog. And I'll put that address up here. I thought I had it in there. But it's at adamjorgensen.com. So if you guys want to, if you'll subscribe to the feed out there, if you guys do that, you'll be able to find and you'll see the updates as they get posted. And I'll try to have those out there here in the next few days. If I forget, please email me or hit me up on Twitter, and I can make sure that I take care of that. Let's see. Where do we verify the settings? From Lori. So to verify the settings, very easy to do. I will show you right now in Management Studio. While that's loading, I'll do another question. Is it being recorded? Yes, we're being recorded. It should be available probably by either later tonight or first thing tomorrow morning. How to determine how much memory is needed to handle all the queries and users in a dedicated AS server. I have a magic set of dice that I use, but they're not the most accurate thing in the world. So what I would really try to do is understand a little bit better about the queries you're going to be running, and then make sure that you understand the volume of data that you're going to be bringing back, and you're going to want to understand about how many users are running those at the same time, and then add all of that up, and then take about 60 to 70% of that to help with compression, and then that's really what you're going to be looking at from a memory perspective as a general rule. Daniel says, when rollup is used, where are the tables stored? Can I see the database instance, and is it created by the SSAS system? So you can absolutely see the tables because the tables are just your data source. So it never actually pulls the data into analysis services. It just acts as a metadata layer when you use rollup. That's one of the reasons that it's so slow from a query perspective, but it's so positive from a data availability perspective. So you want to make sure that you only use rollup. A lot of folks will only use rollup for maybe like the last week's worth of partition or the current day or different things like that. And then the rest of the partitions will be molap or multidimensional rollup. Remember, you can set the storage mode based on the individual partition that you're working with. Back to the question from a couple of minutes ago. In order to verify the settings, if we come over here to analysis services on our server and we say properties, you'll notice a lot of these look pretty familiar. And we've got a lot more in here, of course, as well. Then we can also say show advanced properties. And you'll notice now we get other things like commit timeout and our default directories and locks directories and other things that we're not really ever going to touch. So there's a lot of value in being able to understand what a lot of these different things do. The operations guide talks about a good number of them, as well as the performance guide. If you're working with one and you have a question about one, please hit me up and I'll get you some more detailed information about that particular one and whether it's a good idea to actually mess with it or not in most cases. What do you mean by manually set slicers on partitions? That's an excellent question. So when we come over to analysis services, you'll notice we have a cube in here. And let's go to AdventureWorks and our measure groups, and I'm just going to use this as an example. And I'm hoping, good, still partitioned. Okay. Now, if I were to look at the properties for this partition, I can see the source code here, and we're going to set this source, of course, I didn't mean to make that rhyme. This is not Dr. Seuss hour, but maybe next time. This particular data source right here has a where clause on the end of it, right? Where order date key is less than 2011-12/31. That's really important because we manually set this slice, query binding this, and then manually setting this slice. And then there's also a property in our bids package where we need to set the slice as well and say, look, this is the range. So there's two places where that's going to happen. When you do that in both places, the optimizer is pretty much guaranteed to honor it and not scan that partition by accident, looking for data to make sure that we are getting all the right information that we requested in our query. Can I share the presentation? Guys, I'm going to try to get the presentation up on my blog, but to be honest with you, the best thing you can do is go out to SQLcat.com and look at that operations guide. I just distilled a lot of this down. They have all this information out there. I'll get a link to that posted up on my blog this afternoon. So if you guys will check that out or follow me on Twitter, I'll get it posted up in both places this afternoon. Are there many performance considerations between using a virtual server or a physical server if the configurations are identical? Lori, not really. The biggest one is there's overhead with a virtual server with the hypervisor when it comes to I/O and network latency. So you do have to understand that even with an identical configuration, the virtual server is going to experience a little bit more overhead. It hopefully would not be dramatic unless you're talking about a very, very heavy workload. But still, there are some things in there that you definitely want to consider. Wayne says, is there a recommended third-party tool for monitoring SSAS as opposed to SQL Server? Some of the monitoring folks are starting to build some tools. I haven't been overly impressed with anything that's come out yet. Frankly, it's pretty easy now, especially with 2012. There's some new extended events coming out and other things to really sort of build your own, especially if you run any kind of like OpenView or System Center. Most of the stuff that you're going to run and check for monitoring are going to be perfmon counters. So if you have anything that can capture perfmon counters, even a regular old just data collection trace that you set up that's automated, any of those things will work. But for automated monitoring, you'd want to dump that data down, write a little SSIS package, and dump it down to a table. I like having that data in a table somewhere nice and clean and kind of building my own reports, but there are companies that are working towards integrating more analysis and more things like what you would traditionally see in the relational world into the BI world. And then Wayne has posted a link in here for everybody so that if you guys look at the bottom of the question window, I don't know if everybody can see it, but what we can do is I will get that link posted as well to my blog. I think, Wayne, I'm assuming that's the link out to the white paper. So, guys, if there's no more questions, I want to thank you guys very much for coming. I will get this presentation posted. Again, the recording will be on our website. Check out SQLcat.com. And if you guys haven't voted yet in the past Board of Directors election, please go vote. Just read about the candidates. I've got YouTube videos where I'm talking about the election and all kinds of stuff that are posted out on my blog. You guys can check that out. Go to elections2011.sqlpass.org. I certainly appreciate your vote, but the most important thing is I just want you guys to get out there and vote and be a part of the community. So thank you very much.
All right, thanks, Adam. Just remind everybody you can follow us on Twitter at PWFreeTraining, and you can also find us on Facebook at Pragmatic Works. Thanks, everybody. Have a great day.